So this is 3.2b, the addition property of equality in pre-algebra. We're continuing on with the lecture, and we're going to jump to example number 4, which gives us a minus 3/4. So we're dealing with fractions now, equals 5/8. All right, so again, we're trying to isolate the variable. That means we're trying to get this a by itself, so we want to get rid of this negative 3/4. So in order to get rid of a negative 3/4, we add 3/4. And that will make that go away. So add 3/4 to the other side too. So the left-hand side is easy. It just goes away. But now we have 5/8, and that is 5/8 plus 3/4. So now we have to find common denominators in order to add those. So a equals common denominator of 8 and 4. What is the least common number that both 8 and 4 go into? And in this case it's 8. 8 goes into itself once. 4 goes into 8 twice. So in order to make that 4 and 8, I had to multiply that by 2, which means I have to multiply that by 2. Now I can just add my numerators. 5 plus 6 is 11, and get 11 over 8. And that's the number I prefer. These numbers were fractions. They weren't mixed numbers, so you can leave your answer as just a fraction, even though it is an improper fraction. That's okay. All right, so that brings us to example number 5. And we have 4 times 2a minus 3. We're going to subtract 7a, and we're going to say that equals 2 minus 5. All right, so first thing I like to do is the distributive. I like to get rid of the parentheses first. So let's multiply the 4 times the 2a, and then the 4 times the 3. And then I've got minus 7a equals 2 minus 5. All right, so then I'm going to look here and see if I have any like terms I can combine. I have an 8a and a negative 7a, so I can combine those. 8 minus 7 is 1a, and I'll just leave it as a. I don't have to put a 1 in front of it. Minus 12. I have a 2 minus 5, which is the same as 2 plus negative 5. So signs are different, so I take the difference between 2 and 5, which is 3, and put the sign of the largest number on there. All right, so now I have a minus 12 right here that I have to get rid of so I can isolate it. So I'm going to add 12 to this side, and I'm going to have to add 12 to this side. Makes those go away. And I have a equals negative 3 plus 12. Signs are different, so I take the difference between those two numbers and put the sign of the largest number on my answer. And in this case, it's positive, so a equals 9. And that is it for the lecture on 3.2. Okay, this is the problem set for 3.2 in pre-algebra. If you look at numbers 1 through 10, all they're asking you to do is plug a number in for the equation. So for example, number 6, we have 5x minus 6 equals 9. And then they're saying, what would happen if we plugged 3 in for that x? If we plugged 3 in for that x, would it make that a true statement? And if it does, then that is a solution to the problem. So we're going to put in a 3 for the x, and again, remember to put the parentheses here. And we have 15 minus 6 equals 9. 15 minus 6 is 9. So therefore, 3 is a true statement. It will make that work. For numbers 11 through 26, they're asking you to solve. That means you're trying to find out what number is going to make that a true statement. So I'm doing number 26 here. I figure I'd take one of the harder ones. And we have to get this y by itself. So to get it by itself, we take away 9/2 from both sides. Do one thing on one side, you do the same thing on the other. So this then, when I combine those, becomes 0, so all I've got is a y. But now I've got a 13/2 minus 9/2. And remember, one of the things I suggest doing, change all your minuses to plus and put the minus on the fraction itself or the number itself, making it a negative. So then your adding. So the two numbers have the same sign, so we add the numbers and put the sign on the answer. And 22 over 2, if you divide 2 into 22, you get 11, and that ends up being our answer that makes that a true statement. So numbers 27 to 38 are the same as the ones we just did. We're solving for the variable, but first of all we're going to simplify before we solve. So we're going to do what we can to combine things, and then it'll be simpler when we want to actually solve it. So I'm going to look at 10 minus 6 and get 4. I'm going to look on the left, or these were like terms, so I could combine those. I've got a positive 8x and a negative 7x, so I can combine those. So 8 minus 7 is 1, so I have 1x, and I have a 6 that's left over that I can't combine with anything here. I cannot combine across the equal sign. I have to do some other things first. Alright, so I simplified it. Now again, I'm trying to get x by itself. I need to get rid of this plus x. So to get rid of a plus x, I minus it, and I minus it here. So I have 4 plus negative 6, or 4 minus 6, and I have just x over here because those go away. 4 plus negative 6. The signs are different, so I take the difference, put the sign of the largest number on there, and that equals x. So there is my answer for negative 38. So numbers 39 to 46, same thing. There's an equal sign there, so we're solving for the variable. The only difference is you've got some parentheses. So I want to do 2 of them from this lesson. Let's do number 42. Negative 2x minus 5 plus 3x equals 4 minus 9. So I'm going to distribute this into here. So negative 2 times x is negative 2x. Negative 2 times negative 5, and negative times a negative is a positive, plus 3x, and 4 minus 9 can be written as 4 plus negative 9, which means we can take, because the signs are different, we can take the difference between the two and put the sign of the largest number on there. So we can get rid of this then and just make it negative 5. Save us a little bit of writing. Alright, so now I look for like terms. Well, I have a negative 2x here and a positive 3x here. So because the letters are the same and the exponents are the same, I can combine those. Signs are different, so I take the difference between the two, put the sign of the largest number on my answer. In this case, it's a positive sign, so I don't even have to show it. And I have a plus 10 equals negative 5. This is keeping me from having my x by itself. So I'm going to subtract 10 from there, subtract 10 from there, those go away. And I have x equals negative 5 minus 10, or x equals negative 5 plus negative 10. Signs are the same, so I add and put the sign on there. So my x equals negative 15. That's what makes it a true statement. Okay, this one is number 46, and it can be a little bit tricky, and the part that can be tricky is this right here. We've got a negative in front of the parentheses, and that's it. So what I'm going to suggest you do, at least right now, is whenever there's a negative and there's no number, it's assumed that there's a 1 there. So now I can distribute negative 1 times x and get negative 1x, negative 1x, or negative 1 times negative 7. A negative times a negative is a positive. Okay, and then my parentheses go away. Now I'm going to combine like terms. So my like terms are right there. And of course, you want to square the sign in front of the 2x. And then I also have a plus 8 and a plus 7 and a negative 8, so I'm going to combine those two. Alright, so let's combine negative 1 plus 2x. The signs are different, so we take the difference and put the sign of the largest number, which is a plus sign right here, on the number. Now we've got 7 minus 8, or, I'll do it over here on the right, 7 plus negative 8, because we can always change a minus to a plus negative. And that being the case, we take the difference between the two numbers. In this case, it's a 1. And we put the minus there because the 8 is bigger than the 7 and it's negative. And that equals 4. Alright, so we're still trying to get this x by itself. This minus 1 is a pain, so we add 1 to both sides, and that goes away. So we're left with 1x, or just x, let's just make it x, equals 5. So in order for that equation to work, x has to be the number 5. Alright, so for numbers 47 to 50, we've got some triangles. And let's go ahead and look at number 50. It says that P equals 60. And I've got a triangle here. And I've got an X. And I have a 26. And I have a 10. Okay, so P represents the perimeter. So when I add this, this, and this, I get 60. So when I take 10 plus 26 plus this, which I don't know, I get 60. Okay, we're going to add what I know. So 36 plus x equals 60. Okay, so question is, what numbers or what sign is in front of this 36? When there's not a sign, it's an assumed positive. So I'm going to just put it there. I have a plus 36. That's in the way of this x being by itself. So I have to get rid of it and get rid of 36 there too. Do the same to both sides. That goes away. X equals 60 minus 36, which is 24. So the length of that right there is 24. Okay, let's look at number 52. It says two angles are supplementary angles. Now if you remember right, when you have two angles that are supplementary, that means when you add the two angles up, you get 180 degrees. So if they're supplementary, that means that when you add them up, so if this is 100, this one has to be 80. Those are supplementary. When you add them up, you get 180. All right, so they're saying that two angles are supplementary. I don't know what those two angles are, but I know when I add them up, I get 180. Then it says if one of the angles is 23. Okay, so let's go ahead and erase the 80 and the 100. It's saying one of them's 23. Then solving the equation, so this is the one we don't know. So the angle x plus the 23 that they told us about equals 180. Find out what that other angle is. Well, it's simple for me to do because all I have to do is subtract 23 here, subtract 23 here, because that makes it my x all by itself, and that's what I'm looking for here. So 180 minus 23 is 157 degrees. So that is my other angle that when I add 23 to it, I get 180. All right, so that is some help for the problem set 3.2.